Assalamu alaikum. Welcome to my channel. John. Dependent variable. The quantity which we decide to vary for the experimental purpose is called independent variable. Here time is the independent variable. On the other hand, the quantity which we decide to measure or investigate, that quantity is known as dependent variable. Dependent variable. Remember in y-axis we should put dependent variable. We should put dependent variable. So if the velocity time graph is a straight line, then it shows the object moves with uniform acceleration or constant acceleration. And we can calculate acceleration. We know acceleration A equal to final velocity minus initial velocity divided by time. So acceleration equal to gradient or slope of the velocity time graph. So if we calculate slope, how we can calculate slope? Slope equal to change in y-axis divided by change in x-axis. In y-axis we put velocity, that's why change in delta symbol represent change in velocity divided by change in time. So we can calculate acceleration by calculating the gradient of the graph. We can calculate gradient of the graph. So if velocity time graph, if the velocity time graph is a curved one, then it shows increasing acceleration. Figure 2, increasing acceleration. Because the gradient of the velocity time graph increases with time. So if the graph is a straight line, then remember, if the velocity time graph is a straight line which is horizontal to the time axis, that means gradient is 0, so it represents constant velocity or uniform velocity. So uniform velocity, acceleration is 0. Because the gradient, acceleration is 0 because gradient is 0. Acceleration is 0. So because the gradient of the velocity time graph is 0. Now if velocity time graph is like that, then tell me what type of motion represented by this graph. Figure 3, this decreasing acceleration with decreasing rate, decreasing acceleration, because the gradient of the velocity time graph decreases with time. Because the gradient, look at the velocity time graph, gradient of the graph initially higher, then decreases with time. So gradient of the graph decreases with time. Now velocity time graph, if the velocity time graph is downwards like this, a straight line, uniform deceleration, figure 4, uniform deceleration, uniform deceleration. uniform. So if the velocity decreases, so that means it is negative deceleration. So if we calculate acceleration, we get negative value, negative value, negative value. So negative value indicates that the object is decelerating. The object is decelerating. If the velocity time graph is like that, then non-uniform deceleration, so decreasing deceleration, so deceleration with decreasing rate, decreasing, figure 6, decreasing deceleration, decreasing deceleration. And if the velocity time graph is like that, then it shows increasing deceleration. Figure 7, increasing, figure 7, increasing deceleration, increasing deceleration. Why deceleration? Because velocity decreases with time. And why increasing rate? Increasing rate because the gradient of the graph increases with time. Gradient of the. So remember one thing. If a velocity time graph is like that. So time in the x-axis, time in second, and velocity in the y-axis. Unit is meter per second. Say 0 is the initial time, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, and graph is like that. Here it is 5 meter, 10 meter, and 15 meter. 15 meter. Here initial is 0. If there is a graph like this, so this one is a velocity time O, A, B, C. Tell me from the graph, what type of motion represented in part OA, describing the motion, type of motion in OA. Tell me in the comment section what type of motion represented by this diagram, So look, here OA is a straight line upward, steeper straight line, so uniform acceleration, uniform or constant acceleration. And AB constant velocity or uniform velocity. Why here constant velocity? Because the gradient of the graph is 0. If the gradient is 0, remember, if gradient is 0, then there is no acceleration. So here acceleration is 0. Acceleration is 0. Remember, here acceleration is 0. And in BC part, uniform or constant deceleration. In BC part, uniform deceleration, uniform deceleration. Because if we calculate the gradient is negative. Gradient of the graph is negative value. Negative value of the gradient of velocity time graph represent uniform deceleration. Because it is a straight line, that's why uniform, and deceleration because velocity decreases with time. Now, how we can calculate acceleration for OA part? So, acceleration for OA part. We know acceleration equal to final velocity minus initial velocity divided by time. Here final velocity is 10. Final velocity is 10 meter per second and initial velocity is 0 divided by time 2. 2 minus 0. So, final time is 2 and initial time is 0. That's why 10 divided by 2, so 5 meter per second square. Remember, unit of acceleration is meter per second square. Meter per second square. And if we calculate the acceleration for AB part. So, acceleration for AB part, we know acceleration equal to final velocity minus initial velocity divided by time. Here final velocity is 10 and initial velocity also 10 and time is 5 minus 2. So, 0 divided by 3, so 0 meter per second square. So, there is no acceleration in AB part. Now, acceleration for BC part. BC. We know BC part, V minus final velocity is 0, initial velocity is 10 and time is 6 minus 5, so 1 second. So, minus 10 meter per second square. So, this negative sign indicates that in BC part the object decelerates. Thank you watching my video. If you think this video is helpful for your study in IGCSE and GC O-level physics, then subscribe my channel and share my video with your friends. So thank you very much